Good day, student. My name is Siri, and today we'll be looking at NECOPHYSICS past question. So, get your writing materials and your calculator ready. I'll be right back. Welcome back. Let's dive right into this. The first question here says a particle of charge Q and mass m moving with a velocity v enters a uniform magnetic field B in the direction of the field. The force on the particle is, what I simply ask you here is the formula for force on the magnetic field. And the formula for force on the magnetic field is simply F is equals to BQV. So our correct option there is A. Okay, moving on to question number 2, it says the helium isotope He32 has dash, and we know that if I have helium He32, we know that the atomic number is always equals to the proton number. So if my atomic number is 2, automatically my proton number is also 2. And we know that our mass number is equals to proton number plus neutron number. So if my proton number is 2 and I know that my mass number is 3, automatically it means that my neutron number will be equals to 3 minus 2, and that will give me 1. So looking at the options, look at option A there. It says it has 3 protons and 2 neutrons, which is wrong. It has 2 protons and 1 neutron, which is the correct answer. So the correct answer there is B. It has 2 protons and 1 neutron. Moving on to question number 3, it says when a metal is heated to a high temperature, electrons are emitted from its surface. This process is known as what? This process is simply the thermionic emission of electrons from a heated metal surface. Moving on to question number 4. Question number 4 says a piece of stone weighs 180 Newton. So the weight in air is 180 Newton and 150 in a beaker containing, so weight in liquid is 150 Newton containing 160 Newton of methylated spirit. So the mass of the liquid does not really count as in this case. So we're asked to find the upthrust. And to find the upthrust, all we have to do is tell them that the upthrust is simply weight in air minus weight in liquid. And that will give me 180 minus 150, and that will give me 30 Newton. Moving on to question number 5. Question number 5 says the half-life of a radioactive substance is 2 seconds. Calculate the decay constant. And we know from what we've done on half-life, on radioactivity, we know that the decay constant is always equals to 0.693 over your half-life. So the decay constant is always equals to 0.693 over your half-life. And that means that my decay constant, therefore, is 0.693 divided by 2, because my half-life in this question is 2 seconds. Automatically, this means that my decay constant is 0.347 per seconds. So, and that is option D. Moving on to question number 6, it says which of the following is used in a nuclear reactor to slow down fast-moving neutrons? What to use for slowing down fast-moving neutrons in a nuclear reactor? Option A says graphite rod. Option B, we have carbon dioxide gas. Option C, liquid sodium melter. Option D, we have concrete sheet. Option E, we have boron rod. The correct answer to this question is option A, which is graphite rod. Moving on to question number 7. Question number 7 says, when electrical power is transmitted over long distances, the voltage is stepped up so that dash. Option A says so that the resistance of the wire may be increased proportionately to the potential difference. Option B says the time of transmission between the generating and the receiving stations may be reduced. Option C says there is increased current to produce brighter lights. Option D says the rate of electrical consumption is increased. Option D says the energy waste may be minimized as the current is lowered. The correct answer to this question is option E, which says that the energy waste may be minimized as the current is lowered. So whenever the power is transmitted over long distances, the voltage is stepped up and the current is lowered so that energy waste can be minimized. Okay, moving on to question number 8, it says that a gas occupies a certain volume at 27 degrees Celsius. So we have the volume here is V, a certain volume V, at a temperature T1. So our first volume is V at a temperature of 27 degrees Celsius. Then they asked at what temperature. So we're looking for a temperature 2, which we do not know. At what temperature will the volume be twice the original volume? So they are telling us that our V2 is twice our V1, which is V, assuming that its pressure remains constant. So looking at this question, you can tell that this is Charles' law. And according to Charles' law, we deduce that V1 over T1 is equals to V2 over T2. That is the formula for Charles' law. And if you look at this, if we impute our values, this means that I have V over, at temperature here, you have to convert it to Kelvin, which means I'm going to add plus 273, and that will give me 300 Kelvin. So I have, this is over 300 is equals to 2V over T2. So if I cross multiply, I'm going to be having VT2 is equals to 600V. Divide both sides by V divided by V. It means that my T2 is 600 Kelvin. So we are going to convert our 600 Kelvin back to Celsius by what? Subtracting. So this will give me 600 minus 273. And that will give me that my T2 is 327 degrees Celsius. And that is option D. And that takes us to question number 9. Question number 9 says, what is the coefficient of static friction between a load of mass? So we are given the mass here as 2 kilograms and a horizontal surface if the limiting frictional force is, so our frictional force here is 10 Newton, and we're looking for the coefficient of friction, which is unknown. And we've established before now that our frictional force is the coefficient of friction times the reaction, the normal reaction. And that simply means that if this is what I have, this means that my frictional force is equal to mu mg, because our normal reaction is mg, and they gave us g in this question as 10 meters per second square. So if you input our values, this means that I have 10 is equals to mu times 2 times 10. This means that I have 10 is equals to 20 mu, divide both sides by 20, divided by 20. This means that your coefficient of friction is 0.5. So if you look at our option here, the correct answer to this question is B, which is 0.5. So that takes us to question number 10, which says, when a lever is in equilibrium under the action of 2 or more forces, the algebraic sum of the moment of the forces about the point of support is dash. The option A says anti-clockwise, B says clockwise, C says equal to the product of the forces, D says numerically equal to the total forces acting on it, and option D says equal to 0. The correct option here is E, which is equal to 0. So that takes us to question number 11. Question number 11 says, the specific heat of a substance in the solid state is C1 and its specific bit in the liquid state is C2. So they gave us the specific heat as C1, so we're given C1, and then they said the specific bit is C2, and they said its latent heat of fusion is L. So I have latent heat of fusion as L. So if a mass M of the substance is changed from the solid state at temperature T to the liquid state also at temperature T, the amount of heat required will be dashed. So we are looking for since the temperature does not change, it remains at T, and we're looking for the quantity of heat that will be required. Whenever the amount of temperature does not change, it means latent heat is involved. And whenever latent heat is involved, automatically temperature is not needed. And when the quantity of heat on a substance to change its state is required, what we have is the mass of the substance times the latent heat of the substance. So our correct option here is B, which is ml. So that takes us to question number 12. Question number 12 says an element of nuclear number A and proton number Z. So I have an element, let's say the element is X, and it has a neutron number, a nuclear number of A and a proton number of Z. Emits an alpha particle. So it is removing an alpha particle. So I have an alpha particle. So whenever a substance emits an alpha particle, automatically means that I'm removing 4 from the nuclear number and I'm removing 2 from the proton number. So this is going to give me plus, let's say this is a substance and this will give me A minus 4 and this will give me Z minus 2. So they're asking us what is the number of neutron, the neutron number and the proton number of the new element formed. This is the new element formed. And if you look at that, I have on the new element formed, my neutron number is A minus 4 and my proton number is Z minus 2. So looking at our options, we're going to be looking for A minus 4 and Z minus 2. So that's what I have here as option E. I have A minus 4 and Z minus 2. So that takes us to question number 13. Question number 13 says, the force exerted on a charged body in an electric field depends on dash. Roman figure 1 says it depends on the charge on the body. Roman figure 2 says it depends on the electric field intensity. And Roman figure 3 says it depends on the square of the mass of the body. In an electric field, the mass of the body is not considered. It is irrelevant. So the only thing here that is affecting the force on the charged body and electric field are the charge on the body and the electric field intensity. So we're looking for options that contain Roman figure 1 and Roman figure 2. And that is option C, that contains Roman figure 1 and Roman figure 2. Okay, that takes us to question number 14, which says that 400 grams of cold water, so I have the mass of cold water to be 400 grams, is added to have the mass of hot water to be 200 grams, and the temperature of the hot water is 70 degrees Celsius. And then say if they are properly mixed and the temperature of the mixture, so I have the temperature, final temperature of the mixture to be 30 degrees Celsius. Calculate the initial temperature of the cold water. So temperature of the cold water, we do not know. So from this question, you can tell that this question is based on specific capacity. So looking at this, we know that we're going to apply the law of calorimetry, which says that heat lost is equal to heat gained. And the hot water is the one losing heat, hot water losing heat to cold water. And from our formula for calculating specific capacity, we know that we have what? MC change in theta and MC change in theta. And both of them are water, so they're having the same specific capacity, so that would not be required. So I have the mass of hot water times the temperature of hot water minus final temperature. Here I have the mass of cold water times the final temperature minus the temperature of cold water. So if I impute our values, that means that I have the mass of hot water there is 200 times, and this will give me 70 minus 30 will be equals to 400 times 30 minus temperature of the cold water. So this is same as saying I have 200 times 40 will be equals to 400 times theta of the cold water. So that will give me, I divide both sides by 400 divided by 400. This to 0 cancel out this to 0, 4 here 1, 4 here 1. So that will give me 20 is equals to 30 minus temperature of the cold water. If I collect like terms, this crossover and this crosses over, it means that the temperature of the cold water is 30 minus 10, and that will give me temperature of the cold water to be 10 degrees Celsius, and that will give us, that's option A in our options. So question number 15, it says that the heat from a fire in a closed room reaches someone far away in the room mainly by dash. So this question is based on heat transfer. It is not by reflection, it is not by diffusion. We have three methods of heat transfer. We have conduction, convection, and radiation. And since the person is far away, it means that there is no direct contact with the source of heat. And that method where heat travels through space is called radiation. So this person is going to be feeling the heat at the other end of the room through radiation. So that takes us, that's option D here, and that takes us to question number 16, which says that a solid weighs 5 Newton in air. So we have the weight in air to be 5 Newton, and they say it weighs 4.2 in water. Weight in water is 4.2 Newton and 4.4 in a liquid, wine. So the weight in wine is 4.4 Newton. Then it said calculate the relative density of the liquid. We know that our relative density is supposed to give us weight in air minus weight in liquid over weight in air minus weight in water. So in this case, what I'm going to be having is 5 minus 4.4 over 5 minus 4.2, and that will give me 0.6 over 0.8, which will give me 0.75. So looking at that, you know that our option here is option A, which is 0.75. So that takes us to question number 18, which says that the radioactive substance has a half-life of 3 minutes. So my half-life is 3 minutes. And they said after 9 minutes. So after 9 minutes, after 9 minutes, my number of half-life will be 3, because for each half-life I'm having what? 3 minutes. So 9 minutes I'll be having what? 3 half-life. Then it said the count rate was observed. So the count rate at 9 minutes was observed to be 200. They say, what is the count rate at 0? Count rate at 0 is unknown. So let's call it x. So, and we know that count rate at 0 over 2 raised to power number of half-life is equals to count rate at 9 minutes. So this means that I have x over 2 raised to power 3 is equal to 200. So that will give me x over 8 will be equals to 200 over 1. If I cross multiply, it means that my x is 1600. So at zero time, my count rate is 1600, which is option C. So that takes us to question number 19. Question number 19 says, which of the following is not a part of an AC generator? Which of the following is not a part of an AC generator? I have the commutator, I have the armature, the feed magnets, the carbon brushes, and the slip rings. The option that is correct there is the commutator. The commutator can only be found in a DC generator that converts AC to DC within the generator. So the correct option there is A. So that takes us to question number 20. Question number 20 says, in a simple pendulum experiment, a boy observed the time for 30 oscillations to be 70 seconds, 72, and 67 seconds respectively. Calculate the mean period of oscillation of the pendulum. So the first thing I'm going to find is find the mean time. So our mean time t is supposed to give us t1 plus t2 plus t3. So our mean time here is going to give us 70 plus 72 plus 67. 70 divided by 3 plus 72 plus 67. So that will give me 209 divided by 3. So that will give me 69.67. So that is the time, the mean time for the oscillation. But that is not the period, because we know that the period is the time over the number of oscillation. So that means that my period is 69.67 divided by 30. So if I divide by 30, that will give me 2. That will give me 2.32. So looking at this, it means that my period of oscillation here is 2.32 seconds, and that is option C. Okay, question number 21 says that the clinical thermometer differs from other mercury in glass thermometers because it has dash. Roman figure 1, I have a constriction. Roman figure 2, a wide range. Roman figure 3, a short range. Roman figure 4, I have a narrow bore. Your clinical thermometers have a constriction and they have a short range. Hence, they are used in the hospitals for checking human temperature. So, and going to the options, it says which of the above are correct. Sorry, this is a typographical error, hence it is showing question number 22. This is just a continuation of question number 21. So the correct option there is option B, which says Roman figure 1 and Roman figure 3 only. That is the constriction and the short range. Hence, that is the answer, option B. Moving on to question number 22 now. Question number 22 says, if a positively charged glass rod is used to charge an electroscope by contact and an electroscope Y by induction, then dash. Now, when you use a positively charged rod to charge an electroscope by contact, what happens is that the X electroscope that you are charging by contact will become positively charged. But when you charge an electroscope Y by induction, the electroscope will become induced such that it will become negatively charged because it was induced. So the correct option here is option D. X will become positively charged and Y will become negatively charged. That is also question number 23. Which says, a wave travels a distance of 20 centimeters in 3 seconds. So our distance here is 20 centimeters and the time it took is 3 seconds. Then said the distance between successive crests of the wave is 4 centimeters. And we know that successive crest or trough, the distance between them is always our wavelength. So our wavelength here is 4 centimeters. Then the question is, what is the frequency of the wave? We do not know the frequency of the wave. For us to solve this question, we have to first find the velocity of the wave. And we know that velocity is simply distance over time. So we have to convert our distance here to be in meters, and that will give me 20 over 100. And that will give me 2 over 10 meters. So if I impute that, it means that my velocity here is 2 divided by 10. This is divided by my time, which is 3. So I'll have that my velocity is 2 over 10 times 1 over 3, and that will give me 2 over 30 meter per second. But the question did not ask us to find the velocity. Instead, we have to find the frequency. So for us to be able to find the frequency, we have to find the velocity. Hence, we found the velocity. So we know that our velocity is equals to f lambda. So this means that my frequency is equals to velocity over lambda. And that would mean that my frequency is 2 over 30 divided by, if I convert my lambda here, that will give me 4 over 100. And that would mean that I have 2 over 30 times 100 over 4. 2 here, 1, 2 here, 2. 2 here, I have 50. 0 cancel 0. And that will give me 5 over 3. 5 divided by 3 will give me, and my frequency is 1.67 Hz. So our correct option here is option B. So that takes us to question number 24. Question number 24 says, the unit of inductance is dash. The unit of inductance is Henry, named after Sir Joseph Henry, which is the same thing as saying Weber per ampere. 1 Henry is equals to 1 Weber per ampere. So question number 25 says, a man at the back of a crowd watches a parade by holding a plane mirror just above his head. The parade passes 6 meters behind his head, and the mirror is 0.25 meters in front of the man. How far does the image in the mirror appear to be from the man? So the distance, the object distance from the mirror is going to be the distance of the man from the parade ground, and so that distance of the man from the parade ground, which is 6 meters, plus the distance of the mirror from the man, which is 0.25 meters. So that would mean that my object distance is 6.25 meters. But the question did not ask us for the object distance, but the distance of the man. How far does the image appear in the mirror from the man? So the distance of the man, from the mirror is going to be object distance plus the original distance of the man, and that will give me 6.25 plus 0.25. This means that I have what? 6.5 meters. So our option there is option A. Option A. So question number 26 says, to keep a lorry moving at a constant speed V requires power P from the engine. The force provided by the engine is dash. And we know that power is force times velocity. And if power is force times velocity, this means that force is power over velocity. So the force provided by the engine is power of the engine over the velocity or the constant speed of the lorry, which is option C. So that takes us to question number 27. We say that an electric iron rated 250 volts. So the voltage is 250 volts, has a coil of resistance. So the resistance of the coil is 125 ohms. What is the cost of using it for 1 hour? So the time we are using it is 1 hour at our kilowatt hour. Our cost here is 10 kobo per kilowatt hour. So we are asked to find the cost per kilowatt for using it for 1 hour. So for us to do that, we have to first find the amount of power that was consumed in kilowatt hour. So the power here is V squared over R. That's the formula we're using. So it means that my power here is 250 squared over 125. And that will give me 250 times 250 divided by 125. This will cancel this and this will give me 2, and that will give me 500 watts. But for us to be able to solve it in kilowatt hour, we have to convert our power to be in kilowatts. So divide this by 1000, and that will give me 0.5 kilowatts, or you can simply say 1/2 kilowatts. So the question then is, what is the cost if we are running this for 1 hour at a cost rate of 10 kobo per kilowatt hour, and we do not have up to 1 kilowatt in this question. So what we have to do here is our cost is simply time times our power times the rate. So since our time is 1 hour, we have 1 times our power here is 0.5 times our rate here is 10 kobo. So that would mean that I'll be having 5 kobo as the cost. So at the end of the day, for running your electric iron for 1 hour, you'll be paying 5 kobo. That is option C. So question number 28 says that the image formed by a converging lens of focal length is of a distance of 2f from the lens. So they've given us our focal length as focal length, and they've given us the image distance as 2 focal length. And say calculate the lateral magnification produced, the lateral magnification. For us to find the magnification, we have to find the object distance. And for us to find the object distance, we use our mirror formula that says 1/f is equal to 1/v plus 1/u. So this will give me that I have 1/f is equal to 1/2f plus 1/u. This means that I have 1/f minus 1/2f is equal to 1/u. So my LCM here is 2f. That will give me 2 minus 1 to be equals to 1/f, 1/u. Yeah, so that would mean that I have 1/2f is equal to 1/u. If I cross multiply, it means that my u is equals to 2f. So the question says we should find the magnification, the lateral magnification. Now, for us to find the lateral magnification, we know that our magnification is object image distance over object distance. This means that my magnification is 2f over 2f, which means that my magnification is 1. So looking at our option here, correct answer to this question is option B. And for the last question of the day, it says that if the first position of a resonance in a resonance tube is 18 centimeters from the open end, the distance from the open end to the next position of the resonance will be dashed. So in this question, whenever you have successive positions on the resonance distance is always given as lambda over 2. So for the first position, our length would be lambda over 4. And if that is what I have 18 as the length, which will give me what? Lambda over 4. If I cross multiply, it means that my lambda is 72 centimeters. So the second position here, so we have to look for the second position. So the second position here says that I have what? My length is equal to 3 lambda over 4. And if I have 3 lambda over 4 as my length, and I know that my length is unknown and my lambda is known, so I have 3 times 72 over 4, which means that my length is equal to 4 here 1, 4 here 18. So this will give me 3 times 18, which means that my length is 54 centimeters. So looking at our option here, you discover that what? 54 centimeters is option E, and that is our answer to this question. Thank you for watching to this class, and if you have any questions, just drop it in the comment section. Don't forget to subscribe and turn on your notification button so that when we drop the next video, you will be notified. Thank you.